College of Engineering and Technology. This session about phases of compiler, it comes under compiler design. So what is compiler? Without compiler, we cannot run the computer program. So before getting to the topic, we should know about translator. So what is translator? Translator is a converter which converts the high-level programming language into machine language. So why we are converting the high-level programming into machine language? The computer system or a machine should understand the machine language only. So we should convert the high-level language into machine language. Here we have three types of translator. The first one, interpreter, and compiler, and assembler. The interpreter, which takes the input as source program, it converts the source program into the output. Compiler also converts the high level language into low level language and it throws an error messages. Assembler, it converts the assembly language into machine level language. So a compiler is convert the source program into target program, like high level languages converted into machine language. So the phases of compiler. The phases of compiler have two parts. First one is analysis, next one is synthesis part. The analysis part is converting the source program and getting output like intermediate representation of source code. So the synthesis part is intermediate representation of source code converted into target program. So the analysis part is a front end of a compiler and the synthesis part is back end of a compiler. Here we have 6 phases of compiler: lexical analysis, syntax analysis, semantic analysis, intermediate code generator, code optimization, code generation. These 6 are phases of compiler. These first 4 phases comes under front end of compiler and the next 2 are code optimization and code generation are comes under back end of compiler. And these 2 tasks, symbol table management and error handling tasks, are common for the 6 phases. So here the phases of compiler. So lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer and code generator. Every phase intake the output and give the input to the next phase. So the first phase is lexical analysis. Here the lexical analyzer is scan the source code like a C program, C++ or Java is a source code. So the source code is scanned and the stream of characters is converted into group of tokens. So the stream of character is a lexeme. A lexeme is converted into tokens. Why we are converting it into token? So a computer is a machine language dependent. So a token only it can understand. So pattern. What is pattern? So pattern is a rule for lexeme. And lexeme is a instant of token. So here in lexical analysis, the input is stream of character, which means the source program. The stream of characters. Output is given as token. We can generate the stream of characters as tokens. The token templates or syntax of token is token name, attribute value. Next, this is an example of lexeme. C equal to A plus B into 5. Here a compiler is scanning the source program and give the lexeme as the input for lexical analyzer and then generate the tokens from lexemes. So here C is the identifier, A, B also identifier, equal assignment operator plus additional operator and this is multiplication operators. Here the token is generated like id1 equal id2 plus id3 multiplication. This is a number. So this is what generating tokens from stream of characters. The next phase is syntax analysis. Syntax analysis generate the parse tree. So what is parse tree? We are going to split the lexemes or token into tree format. So parser converts the token produced by lexical analyzer into tree-like representation called parse tree. Here in previous slide we know that we are split the lexemes into token. So here we have C as a ID, AB also ID, equal assignment statement and plus expression, multiplication expression, 5 as number. And the syntax analysis part is takes the token as input and generate the syntax tree. Here we remove all the unwanted or temporary variables and give the permanent variables as a syntax tree. So next one, semantic analysis. So semantic analysis is nothing but type checking. So what is type checking? Here the data types is converting from int into float. If we are declaring the C variable as float means we should convert the integer value into float. Other than we don't want to convert it. So because the float value is declared means the C is only accept the floating value. So it comes under semantic analysis. Not only the data type, the control flow, data structure also checking under semantic analysis. This is a third phase of phases of compiler. Then intermediate code generator. This is a fourth phase of compiler. Phases of compiler. Intermediate code generator is nothing but it takes the input from syntax analyzer as syntax tree and then generate the intermediate code. Intermediate code is in three forms. First one is postfix notation. The second one is 3-address code. Third one is syntax tree. Here we take 3-address code for our program. So 3-address code is nothing but we generate the intermediate code from the syntax tree. So earlier we generate a parse tree and then it converted into syntax tree. Here we generate the intermediate code from syntax tree. Here T1, T2 and T3 are the temporary variables. Here we have 4 lines for calculating the lexeme. So next phase is code optimization. Code optimization is nothing but the shortest or best way for solving the problem. Here in previous stage intermediate code generator we have 4 steps for solving the lexeme. Here we have only 2 steps for solving the lexeme because we are reduce the number of line and then remove the unwanted variables, which means temporary variables. We are going to remove the temporary variables for improving the efficiency of source program. So that is code optimization. And detect the error, unreachable code like deadlines, white spaces. We are going to remove the white spaces and remove the temporary variables in code optimization. Then next phase is code generation. The 6th phase of phases of compiler is code generation. Code generation is nothing but from code optimization we get a final code to implement. So here the memory allocation in code generation. Here we have R2 as ID3 in 5.0. This 5.0 is converted variable, which means we are converting int value into float value. So this is multiplication function. This then generation of missing code. So next one is symbol table management. Already I said simple table management and error handling are common for 6 phases. Here first one is symbol table management. Already we have seen in lexical analysis part, we have a table which consists of lexemes and tokens. So a source program is scanned and converted into tokens. Thus tokens are stored in symbol table. So symbol table is used to store the informations like tokens and lexemes. So and also address code of the tokens. Then next one is, so this is an example for symbol table management. So here we have int AB and float C, char C. This is a lexeme. These are lexemes. These lexemes are converted into tokens and placed in symbol table. These are data types of A, B, C and Z, and these 4 are address of those variables. And next one is error handling. Every phase of compiler encounters an error, which means lexical analysis throws an error like while scanning the program it throws an error like data type error or syntax error. So next when we separate the tokens, the lexical analysis throws an error. Then next one, syntax analysis. During the construction of syntax tree, it may send an error. Semantic analysis. So during type conversion or construction of syntax tree, it may be throws an error. So thank you. This all under phases of compiler. Already I said 6 phases in phases of compiler: lexical analysis, syntax analysis, semantic analysis, intermediate code generator, code optimization and code generator. These 6 phases are comes under phases of compiler. While we are compile the C program or Java program like any other high level language, the compiler will convert the high level language into machine language. Okay, thank you.